So in today's lesson, we're going to talk about piecewise functions. And piecewise functions are functions, like we talked about yesterday, where one x goes to at least one y, right? That one x cannot go to multiple y's, but it can go to at least one. So let's start here by just thinking about this problem. So think about an airplane flight. Right? We're going to fly to Disneyland, which is in California. Okay, for the first 30 minutes, we're going to fly from an altitude of 1,000 feet, climbing all the way to 40,000. Then for the next 3 hours, we fly at that cruising altitude, and the plane's going to spend the last 30 minutes descending to 100 feet where we're going to land. So let's look at this here, this x and y, this coordinate plane here. So let's start with the y's are going to be, okay, these are going to be the altitude in feet. So then we're going to count in thousands. We're also going to look here at the x-axis. This is going to be time in hours. Okay, so those are our x values. So the first thing it says is, okay, we're going to start at 1,000 feet. So, right, 1,000 feet at time here is going to be right about there. Every box here is looking at about 2,000. Okay, and so it says for 30 minutes, we're going to climb from that 1,000 to 40,000. So it's telling us, okay, here are 2 points. So if I highlight that little section, right, I'm going to start at time 0, and at time 30, there is the first thing. And so if I make a line between those, I apologize here, I'll move it over there so it works, right? So a line starting at time 0 at 1,000 feet to 40,000 in 30 minutes. Okay, now in a different color, if I highlight the next section of our flight, we're going to spend 3 hours of this flight now. Okay, the blue section. So 3 hours of this flight at 40,000 feet. So 3 hours is 1, 2, 3 hours. Okay, so at 3.5 hours into our flight, we will start descending. So again, we're going to stay at 40,000 feet for that whole thing. And you can see there, creating that line, it should look something like that. Okay, and now what happens? Okay, so let's look back at the problem. So then it says, okay, in the last 30 minutes, we're going to descend to 100 feet. So now, in a different color, okay, we got 30 minutes to get back to Earth. So now the green part of our flight, 30 minutes. So from 3.5 to 4 hours into our flight, we're going to work on getting down to 100 feet, which is going to be almost down here to the x-axis. So start there, and we're going to descend. Again, how the and so here, this is what our flight looks like. And it looks like, okay, we have some different parts. So if we look at the graph, can we come up with one equation that does that? Which, unfortunately, I don't think we can, right? There's no equation or no function that we know at this point that we know about. So the answer there would be no. But, right, and so we said no, okay. But if no, how many equations could we do? Well, how many parts or how many different colors did we highlight with? We highlighted with 3 different parts, so we could write 3 different equations. So we could write those 3 different equations to make this look good. And each of these equations would be what type? Would they be lines? Would they be circles, right? Whatever it is. So at this point, we only have really talked about linear functions, so we're going to stay with that linear idea. Okay? So they would all be linear functions. So what we're saying is we would have 3 linear functions that would make up this idea of our flight. And so what we're going to talk about in this little video is talking about, okay, how do we write piecewise functions and use them? So now moving on to page 24 in your book, let's look at a problem. Okay, so this problem is an example of a piecewise function. And you can see, okay, 3 different. So there's 2 ways we can interact with it. First is we graph them, and second is we'll actually evaluate them. So here's just an idea. There's 3 pieces. if I highlight them, right, this first one, it's going to be this first line here. Then we have the green piece, which is just actually a point here. It's not a linear equation. So we're going to deal with linear equations, but we will also deal with points. Okay. And so there are the three parts, right? And so if you look down in the words here, it does talk about, okay, we have different sub-functions, right? So as a part of the big function, we have those three functions, the blue part, the green part, and the purple. And each of those has subdomain and a domain restriction like we talked about yesterday. So we're restricting the x values for these two. So for the blue one, this function will only appear between when x is -7 and x is -2. And then in the green part, only when x is -2. And in the purple part, only when x is between 0 and 4. So in all the problems that we do, these right here, these restrictions, the domain and interval notation, they will all be domains, so x values. So that's something to keep track of. So what is a range of this function? Okay, again, range is y values. So if we're looking at the y values here, remember what we did in class was we looked at this and we said, okay, where does y start? So what is the smallest y to be? And if I drew a line there, that would be where the y starts. And we start moving up, and we're moving up, we're moving up, and at all these values y is appearing, right? Until we get to that 5. And that is where y stops. So what would the range be here? Well, the smallest it could be was -3, right? -3. And the largest it could be was 5. And at both of those points, they were filled in, so they would be brackets on both sides. So that was talking about the range, the y values. Moving on to page 25, or 125, excuse me, in our book. So now let's talk about something else. So take this equation here and write it into a function, a piecewise function, and change these notations here into interval notation. So again, x is greater than 3. So how would we write that? Okay, the smallest x could be is 3, and the largest it could be is infinity. And then here x is less than or equal to 3. So negative infinity to to +3. To 3 with the bracket on that side. Okay. So the way they have this written, okay, is in these two functions. So I actually would change, and I always want you, and the way I always do it is I would change this to write it so the interval with the negative infinity or the smallest notation comes first. So +2, and since negative infinity comes first, we're going to put that first there, and then 4x minus 3, and from 3 to infinity. And the reason I say that is that we can always start from the left. We will always lead from the left, so start from the left and we can just read from left to right and down. And so next thing it says, okay, we called this f of x. So now let's look, okay, look at this. It's saying f of x when x is negative. How are we going to do that? So when we do this, we're going to say, okay, we need to look where -2 is. Which interval is -2 in? Is -2 in between negative infinity and 3, or 3 and infinity? Hopefully you decide it's between negative infinity and 3. So what we do is then we plug x into that -2 into that top part of this equation. So it ends up being plugged into -2 plus 2, negative 9 plus 2, 8. So that would be the equation, right? And so we want to look at all these, right? So why don't you try 4 and 0 on your own? And we'll look at 3 here together quickly. So here, which does 3 go in? Well, 3 is interesting because 3 is in both of these intervals. But remember that that bracket means that it is the less than or equal to, where the parentheses means it can never be 3 in this bottom one. It can get as close as possible to 3, but can never be. So we would end up plugging 3 into that top, or sorry, the top equation as well. which is 5 times 3, 2, so why don't you spend time to do those other two, and then we'll reconvene, pause the video, do those, and then start the video back up. Okay, so now looking at those, you should have had f of 4 was 13 using that bottom equation, and f of 0 was 2. Okay, so that should end this video here. There's one more video that's going to be on part 2, and that's actually going to be graphing these. So this is going to end that intro part. Now we'll move on to part 2 in the next.